Hey guys, in this video, I'm going to be going over questions 15, 16, and 17 from the 2017 AMC 12B. Question number 15 reads, let ABC be an equilateral triangle. Extend side AB beyond B to a point B prime so that BB prime equals 3 times AB. Similarly, extend side BC beyond C to a point C prime so that CC prime equals 3BC. And extend side CA beyond A so that AA prime equals 3 times CA. What is the ratio of the area of A prime, B prime, C prime to the area of ABC? So the first thing we have to do here is to draw a triangle ABC and label the side lengths as X because it's an equilateral triangle. AB gets extended beyond B, and we know that BB prime is going to be 3x. And similarly, we're going to have CC prime equals 3x and A prime, A prime equals 3x. If we connect A prime, B prime, and C prime, we're going to get a new triangle which happens to be equilateral because of symmetry with the equilateral triangle ABC. So we can call each of these side lengths y. So the next thing we have to notice is that ABC is an equilateral triangle, so all of its angles are going to be 60 degrees. And that means that ACC prime is going to be 120 degrees. Since we know this side, and this angle between the two sides, we're going to be able to figure out the relationship between x and y using the law of cosines. So we can establish the equation y squared equals the quantity 4x squared plus the quantity 3x squared minus 2 times 4x times 3x cos 120. Cosine of 120 degrees is negative 1/2. So negative from here cancels with this negative to make it positive, and 1/2 cancels with 2. So we're going to be left with y squared equals 16x squared plus 9x squared plus 12x squared. So y squared is going to be equal to 37x squared. So we know that y squared over x squared is 37. So next, we have to use the concept that the ratio between two similar shapes is equal to the square of the ratio between the two corresponding sides. And the ratio between the two corresponding sides is y over x. If we square that, we get y squared over x squared, which happens to be 37, and our answer is going to be E. This is problem number 16. It reads, the number 21 factorial has over 60,000 positive integer divisors. One of them is chosen at random. What is the probability that it's odd? So the hardest part of this problem is thinking about how to approach it. So for this problem, what we have to do is actually to find how many factors of 2 are in 21 factorial. And if we have, say, x factors of 2, the answer is going to be 1 over x plus 1. And the reason for this is this one case up here is going to be the case where we choose 0 multiples of 2, and thus the divisor is going to be odd. And these other x plus 1 cases are going to be the cases where we have 0 multiples of 2, 1 multiple of 2, 2 multiples of 2, up until x multiples of 2. So, and now this question becomes how many factors of 2 are in 21 factorial, right? Because once we get that, we can just plug it into this equation and get the answer. And it turns out that we actually have a formula to solve things like this. So if we have a number n factorial and we want to find how many factors of a are in it, the answer to this question is going to be n, floor function of n over a plus the floor function of n over a squared up until the floor function of n over a to the infinity. So while this might seem like a lot, we actually just have to start adding until the point where a to the, let's say a to the k is greater than n. Because after that point, these floor functions are all going to be 0. So we only have to compute the sum up until that point. So if we go back to our problem, we're going to have 21 over 2, the floor function of 21 over 2, plus the floor function of 21 over 4, plus the floor function of 21 over 8, plus the floor function of 21 over 16. And after this point, we're going to have the floor function of 21 over 32, or 21 over 64, and all those are going to be 0. So we only have to compute this sum right here. So the floor function of 21 over 2 is going to be 10 plus 5 plus plus 2 plus 1, which is 18. If we plug 18 back into this equation, we're going to get 1 over 19, and that becomes our answer. So the probability is 1 over 19, which is B. So this is question number 17. It was really long, so I kind of wrote a summary here. Basically, the question gives you a coin where the probability of heads is 2/3 and the probability that you flip tails is 1/3. And the outcomes are independent from each other, right? And there's two different games, game A and game B. With game A, you flip a coin 3 times, and you only win if the outcome is the same every single time. And with game B, you toss the coin 4 times, and you win if the outcome of toss 1 and 2 are the same, and the outcome of toss 3 and 4 are the same. So first we can calculate the probability of game A. It's a lot easier because you only have 2 cases, right? Either you flip heads, 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 or you flip tails, tails, tails. The probability that you flip heads, heads, heads is 2/3 cubed. And the probability that you flip 3 tails in a row is 1/3 cubed. So this is going to be 8 over 27 plus 1 over 27, which is 9 over 27, which is 1/3. And game B, you have 4 tosses, right? So you can either have heads, heads, tails, 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 heads, heads, or 4 tails in a row and 4 heads in a row. The probability of these two are going to be 2/3 cubed, or 2/3 squared, sorry, times 1/3 squared. And since these are going to be equal to each other, you can just multiply this by 2. 4 heads in a row is going to be 2/3 fourth. 2 tails in a row is going to be 1/3 fourth. So if we just solve this, we're going to have 2 times 4 over 9 times 1 over 9. So this is going to be 8 over 81, I think. 8 over 81 here. 2/3 to the fourth is going to be 16 over 81. And 1/3 to the fourth is going to be 1 over 81. So this is going to be 25 over 81. And the problem is going to ask us to, I didn't write it down, but the problem just asks us to find the difference between the probability that you win game B and game A. So 1 over 3 is going to be, I think, 27 over 81. So you have 27 over 81 minus 25 over 81, which is 2 over 81. And so the probability that you win game A is 2 over 81 more than the probability that you win game B.